Hello students, now I am going to introduce the syllabus for our subject ME22077 Sensors and Instrumentation. Here lecture hours are 3, tutorial hours and practical hours are 0 and it is given 3 credits. You can score all 3 credits if you do well, and it is a theoretical subject and very easily you can score good marks. Objectives of this subject, there are four core objectives: to understand the working principles of various sensors and instrumentation used in automation engineering, to learn about signal conditioning, data acquisition systems, and interfacing of sensors, to apply various sensors and instrumentation knowledge in real-world mechanical engineering problems, to gain the expertise in designing and implementing sensor-based systems. So these are the four core objectives. Keeping these objectives in mind, you have to study this course, and once you complete the subject, there are few objectives you have to achieve them. So that is, they are the course objectives and the course program, course outcomes. Course outcomes you are going to achieve based on the syllabus we have here. Coming to introduction part, introduction to sensors and instrumentation. This comes under first unit. Overview of sensors and instrumentation. Classification of sensors, active versus passive, analog versus digital, static and dynamic characteristics of sensors, classification of errors, error analysis, sensor calibration techniques, sensor output signal types, introduction to common sensors like temperature, pressure, flow, level, direction, range, and force sensors. So these are the basic type of sensors we are going to study under Unit 1. So there are 9 hours required to deal this unit. We can easily complete in 9 sessions here in hybrid mode. Unit number 2, signal conditioning and data acquisition. Again, signal conditioning is very important concept in sensors. Suppose you have a sensor, and sensor normally produces in terms of signals only. These signals are non-understandable. You cannot understand anything. You cannot extract any data from these raw signals. Then you have to process it. You have to process it into some understandable format, readable format. For that, you need this aid that is known as signal conditioning. So signal conditioners are required. So now with this signal conditioner, right, you will be producing some output that will be readily usable. You can transmit it, or you can record it, or you can display it. So that is why you have signal conditioning. And data acquisition, basics of signal conditioning. Again, there are so many techniques involved: filtering, amplification, linearization, and analog to digital conversion, digital to analog conversion, sample and hold circuits, data acquisition system, components of data loggers, configurations and applications. Role of LabVIEW. I'm going to introduce one software, LabVIEW, in data acquisition and signal processing. Interfacing sensors with the control systems, PID controllers. This is the unit number 2, and under unit number 3, we have motion and proximity and ranging sensors. These are the 3 types we are going to deal here. Motion sensors are like potentiometers, resolvers, encoders. Encoders are different types: optical, magnetic, inductive, capacitive. We have LVDT, RVDT, synchro, microsyn, accelerometer, GPS, Bluetooth, ranging sensors, RF beacons, ultrasonic ranging, reflective beacons, laser range sensors, that is LIDAR. LIDAR is another widely used type of sensor. Under unit number 4, we are going to see force, magnetic and heading sensors, strain gauge, load cell, magnetic sensor types, principles, requirement and advantages, magnetoresistive Hall effect current sensor, heading sensors, compass, gyroscope, inclinometers, real-time implementation, and we are going to see here. Optical pressure and temperature sensors as part of unit number 5. Photoconductive cell, photovoltaic cell, photoresistive LDR, fiber optic sensors, pressure sensors like diaphragm, bellows, piezoelectric tactile sensors. We have temperature sensors like IC, thermistor, IC in the form of a chip with which you can measure the temperature. RTD, thermocouple, acoustic sensors, flow and level measurement, radiation sensors, smart sensors, film sensors, MEMS and nano sensors, laser sensors. And course outcomes. So this is our from objectives we have seen at the beginning. Once you complete the syllabus, you are supposed to acquire these outcomes. You are supposed to satisfy these outcomes. Identify and describe the working principles of various sensors and instrumentation. Design and implement sensor-based systems for measurement and control. Analyze and interpret data from sensors for use in mechanical engineering applications, integrate sensors with control systems to automate mechanical processes, evaluate the performance and instrumentation systems in terms of the different desirable characteristics like accuracy, precision, reliability. All those are desirable characteristics that we are going to study under static characteristics of sensors. Dublin Patranibus, these are the two very standard books. Dublin Measurement Systems Application and Design. Patranibus, we have sensors and transducers, both are very good books. Apart from these two, we have three more references, Webster, Rectin and Murthy. These are again three resources, three references, very good references you can refer. And next we have, they are IEEE digital library, NPTEL, Coursera, edX, and we have do-it-yourself projects documentation from Arduino and Raspberry Pi official websites. You can refer this and you can definitely explore many types of sensors and instrumentation. Those are used in automation field. In coming sessions, we will start the syllabus right from first unit. We will discuss all the topics elaborately and in detail. Thank you once again. Thank you, students.